Assalamualaikum, my name is Muhammad Shami. I'm Muhammad Zainuddin. My matrix number is AE20035. So today I'll be presenting for my group about manual calculation. So as you can see, our circuit is, the first voltage is 50 volt and the resistor value is 50 ohm, and our inductor is 20 millihenry, and our capacitor is 5 microfarad. So this is our graph, which is Vs, voltage across time. So for the voltage across time, for the 50 volt, for the time between 0 and 1, so A is equal to 50 volt, which is our DC source, so time is 2 seconds, and W is equal to 2 pi over T. So for the voltage, first A0 equal to sigma infinite n equal to 1. So An, this is our formula that we use to calculate the voltage. So An cos n omega delta time plus Bn sine and omega naught time. So AO is equal to 1 over T. So the time limit is T, limit is 0 from 0 to T. So the V is equal to AT dt equal to 1 over 2. So the time limit is 0 to 1 second. So 50 dt plus for the second for the second time is 1 to 2 second, which is 0 value of voltage dt. So it's equal to 25. So for the An is 2 over T time. So the limit is 0 to time, and then we plug in the value into the formula, which it will get 50 equal to 1 over n pi sine n pi t. The time limit is 0 to 1 equal to 50 n over n pi in bracket sine n omega pi 1 minus sine n pi 0. So since n pi n is equal to 0, 1, 2, 3, so the sine n pi is equal to 0. So thus An equal to 10 over n pi in bracket 0 multiplied by 0. So when it multiplied by 0, we will get 0. So after that, for the Bn, we'll get, for use calculation, this, which is 2 over T. The time limit is 0 to T. Vs time sine n omega naught plus dt equal to 2 over 2, which is 1. So the time limit is 0 to 1. 50 sine n pi plus dt equal to negative 50 over n pi in bracket cos n omega t in modulus 1. Yes, modulus 0 to 1. The time limit, sorry. So after that, we will get the answer negative 50 over n pi in bracket cos n pi 1 minus cos n pi 0. So since cos n pi equal, so this is our calculation. We'll use the same equation for the above, and after we plug in, we'll get the answer. The last answer is which is Bn equal to 50 over n pi in bracket 1 minus 1 power of n. So for the voltage across time, we use this formula, A naught plus sigma infinity n is equal to 1, An cos n omega naught time plus Bn sine n omega naught time. So after we plug in the value 25 we'll get the answer 25 plus 50 over pi 1 over n sine n pi t time which is the n is equal to 2k minus 1. So this is our amplitude. The formula is set an squared plus bn squared. So for the above is 50 over n pi, so this is which is the n is odd, so when it is 0 the n is even. So this is our amplitude spectrum. This an 25, so the pi is 50 over pi, and then 2 pi, 3 pi, 4 pi, and 5 pi. So for the phase, this is our phase spectrum. So the negative 90 degree is odd and 0 is even. So our pi, 3 pi, and 5 pi is negative, which is odd. So for the S domain circuit, this is our voltage. 25 plus 50 over n pi 1 over n sine n pi plus plus pi t, which is the n is equal to 2k minus 1. So for the DC components, Vs equal to Va multiplied by Va, so this is the output. Voltage at each load is this equation Vs equal to Va multiplied by Va, so that is the output voltage for the each load. So Vs is equal to Va, which is the 25 volt. So for the AC components, Vs is equal to Vo, V0 equal to 550 over n 2k minus 1 pi. So less than negative 90 degree volt. So then when it's negative 90 degree volt, so the n is odd. So this we are using V across time, our calculation, our formula. After we plug in the value, we'll get the answer 25 plus 15.9155 cos pi time negative 90 degree plus 5.3052 cos 3 pi t minus 90 degree, and then plus 3.1831 cos 5 pi t minus 90 degree, and then plus for the next sequence until it reach its limit. And this is the voltage Vs is equal to Vr, Vl, and Vc, since the circuits is parallel. So the current at each branch is represented by V equal to IR, Iz. So I equal to V over Z to find the current. So for the first current at resistor, the equation is 50 plus 20 over n pi, which is n is 2k minus 1. So the answer will get, after you plug in the value in this formula, we'll get the answer is 1 plus 0.127 cos n time negative 90 degree, and the sequence until it reach its limit. So for the current at inductor branch is 50 plus 20 over 2k minus 1 pi less than negative 90 degree over 1 is the voltage, which is the 50 divided by 50, so we'll get 1. And then the final answer for the current at inductor branch is 20.264 cos n time negative minus 180 degree, and the sequence until it reach its limit, and the unit is ampere. And for the last current at the capacitor, which is 50 plus 20 over 2k minus 1 k, so less than negative 90 degree, divide by 50k less than negative 90 degree over 5 pi 2k minus 1. So we cancel each other, we cancel, and then we will get 0, which is the 50 minus 50. So we'll get 0 plus 2 over 5k equal to 5. So 5000, which is 2 divided by 5000, we'll get the answer for power exponent negative 4 ampere for the current through capacitor. So the power at one load, which is we use to calculate the power at resistor load. So for the resistor load is 15 voltage, bracket 1 plus 1 over 2, 20 divided by 2k minus 1 pi, and then multiply by 0.4 over 2k minus 1 pi, and then cos in bracket negative 90 degree minus negative 90 degree, and after we simplify, we'll get the answer is 50 plus 1.273 plus 0.424 plus 0.255 until it reach limit. So the unit for power is watt. So it's it for the explanation for calculation, manual calculation. So thank you.